Okay, now we are truly ready to derive the mirror equation. So I'm going to take a concave mirror. So this is a mirror. And this is the axis. This is the axis of the mirror. Let's say this is my F. Let's also say this is my C. Maybe this is my C. The focal point, and that's my center. The center of the sphere, the spherical mirror. Okay. Okay. Let's say that I keep the object somewhere here. Okay, I have an object here, a line object. So, does it mean that I should keep it above this? No, it's not. I mean, I can keep it like this also. Doesn't matter. Then what will happen now? Then the rays below this will appear here. Okay, this part. Instead of keeping it like this, if you keep it like that, then you see, then the image will, part of the image will go up, reverse. That's all. Okay. But what happens to one half will happen to the other half too. So if this is going to produce an image here, then the object here will produce an image on the other side. That's it. So we're simply just simplifying it. It's about it. So should I have only a line object? No. I can have an object like this also, right? Like this. I can have an object like that. So in that case, it's not just a line. Okay, like it's an object. This will act like that, and you know this will do this its own stuff. But from every point, millions of rays will go and then get reflected, and you will have a two-dimensional picture. Okay. Okay, here like you have one-dimensional image. But if I have a two-dimensional object, then I can have a two-dimensional picture. But then it's difficult to show it here, and that is why we are doing it like this. So, if what happens to one line will happen to all the other lines in all directions. That's all. Okay, so I call this as A and B. So A is the top and B is the bottom. I'm going to use a couple of rays, okay, to find the image. First, I'll take this point, yeah, the top, and I'll take the bottom. So, and all the other points should lie in between the top and the bottom. We know that. Okay. So this is going to be my first. I'll choose this. The parallel ray, the ray parallel to the axis will go through F. Like this. Right? You agree? Okay. And then I'll call this as M. Okay? The mirror point, the point at which this is M. And then this would be my P. The pole of the mirror, right? So M and P. Okay. So I need to know which point is where this is going to make the image, right? So I need one more ray, at least one more ray. I can have a million rays, just one more ray is enough for me. So this time I'm going to take this ray, the ray which hits the pole and then gets reflected on the pole. Okay, let's see. The ray that hits the pole, okay, and then this is theta, and this will also be theta. See. This is the point. Okay. Right? So this is the top. And the bottom, again, it will go here. And then it will get reflected back. It will come back like that. Right? And I can draw one more, but then I know that it is vertical, and this will also be vertical. So the image will be formed somewhere there. So I'll call this is C, this is F. Now A makes an image here, so that is A dash. B will make an image here, so that is B dash. So everything else, X, Y, Z, all that along this will make an image along this line. So I have this in place, right? Okay. Now, what am I going to do? I'm going to make use of this geometry and arrive at the mirror equation. First of all, if we take this triangle, okay, this triangle ABP, triangle ABP, ADP, triangle ABP, ABP, and this triangle, and you see this triangle, which is triangle A dashed B dashed P. These are similar triangles. Okay, so there ABP, this triangle, and A dash B dash P, they are similar triangles. You know why? So notice that this angle is the same as this angle, 90, and this angle is the same as this angle. Okay, so there must be, and the third angle, if these two angles are the same, the third angle must be the same. So by that rule, then these two are similar triangles. Okay. So what does it say? So I'll say if they are similar triangle, then AB by A dash B dash must be equal to, I'm going to take the horizontal distances. Why would I take horizontal distances? Because that is where I will have U and V, right? U is the image object distance and V will be the image distance. So I will take the horizontal distances. Right? For the AB with this triangle, horizontal distance is BP. And for A dash B dash P, the horizontal distance is B dash P. Okay, so this is one equation. And then what is the second one? Well, I need the focal length, yeah, UV, and then I also need F, right? So where is this F thing? It's here. So can I take this triangle A dash B dash F, triangle A dash B dash F, and F M, well actually this will be something else. If I drop it here, if I drop this, like if we make it a right angle triangle, then this will be slightly below F, so before F, before P, sorry about it, before P. But you see, a mirror like this, how different is it? That's the whole point of paraxial lines, right? If you use paraxial lines, if the curvature is so small, then this distance will be the same as this distance. So I can kind of treat this M and P as kind of a straight line. Okay? There's not much of a distance between, much of a difference between this distance and this distance. Let's say I call it as N, CN, and CP, or other, anything. I call this as N, okay? And so I'll take this. Anyway, triangle A dash B dash F and F M N, and triangle F M N are similar triangles. Okay, so I'm going to drop this. But again, N and P are so close that I could take just P instead of N. Let me not do it now, so I'll just take it as N. Okay. Now, let me do the same thing. Mn by A dash B dash mn by a dash to b dash is equal, taking horizontal distances, right? So m and f, so that's going to be fn by, this will be b dash f, b dash f. Okay. Okay. So this mn is the same as AB. So this will become AB by a dash to b dash. This is equal to Fn is the same, it's approximately the same as Fp. Right? It's almost the same. Okay. That's the whole point of paraxial lines. Where we are very close, then that difference can be ignored. Okay. So this is going to be Fp, so divided by b dash f. Okay. So you see, this is equation 1, this is equation 2. So 1 is equal to 2. AB by a dash b dash, AB by a dash to b dash. So BP by b dash p must be equal to FP by b dash f. So BP from 1 and 2, BP by b dash p is equal to FP by b dash f. Okay. What is BP? BP is actually the object distance. Here, BP is actually the object distance which you call as u. Some centimeters, u. Okay. U. B dash P is actually the image distance. B dash P, image distance V. So if I do this here, BP is U by V, which is equal. What is FP? FP is the focal length. The focal point from the pole, it is the focal length F. Okay, it's going to be F divided by. Then what is FB dashed? I'll say FB dashed. FB dash can be written as PB dashed minus PF. PB dashed minus PF. What is PB dashed? We saw that PB dash to B dash P is V minus, this is F. So I get here V minus F. Okay. So this is what you get. Now solve for F. What do you get? I take this here, I get U into V minus F equals VF. Multiply UV minus UF is equal to VF. Then take it there, UV is equal to VF plus UF is equal to U plus VF or V plus UF. Then F or 1 by F. Okay. Neither find F or 1 by F, right? So if we find F, this is equal to UV by V plus U. Okay. If we find 1 by F, this gives me 1 by F is equal to V plus U by UV, and that is equal to V by UV plus U by UV, and that is equal to 1 by U plus 1 by U. So that is another way of doing it. So this is what we call as the mirror equation. Notice that we are not using any sign conventions here. We have just taken the absolute distances, 10 centimeters, 20 centimeters or whatever. We are not using any sign conventions here. But we got this UV, UV plus UV. Okay. But why is sign convention important? Why are we even talking about sign convention? Okay, so this is what we found as a mirror formula, right? So F is equal to UV by U plus V or V plus U. That's what we found as a mirror formula. This is without any sign convention. And when the object was beyond CU, okay, when it was making an image. Okay. Now, let me use the same approach, but then I'm going to keep the object at a different place. And then let us see what kind of formula I'm going to get. Okay, I have the same mirror, and this is the axis, and this is F for me, and this is C for me. And now, initially I kept the object here, right? Now I'm going to keep the object here, and this is P. So I'm going to have the object here. That is between the pole and the focal point within F. Okay, so this is my A, this is my B. So what is going to happen? Well, I'm going to use the same rules. What are the rules? The parallel ray that comes here, that must pass through the focal point. After reflection, it passes through the focal point. And the ray that hits here will obey law of reflection. What is this? You see, there is no convergence that is taking place here. Okay, so it's diverging. Okay. So I can't have a real image. By the way, what is a real image and what is a virtual image? A real image is an image that you can capture on a screen. Okay? For example, I have this. This is a screen, and you notice that I am able to capture the image on the screen. The image is formed on the screen. So this is a real image. This is a real image. But if I cannot capture it on a screen, then it is a virtual image. So like this, when you look at yourself here, you see this cannot be captured on a screen, but you can see a bigger finger in the mirror. You can see an image, but that cannot be captured on a screen. So this is a virtual image. The virtual image is what you see on the mirror. It will appear as if it is on the other side of the mirror. So this is a virtual image. But if you can capture it on a screen like this, there is a bus in front of you, then you can see that it is captured on a screen. It's upside down. The window can be captured on a screen. So this is a real image. Okay? You won't see it in the mirror. You can't see that in the mirror. It's captured there. You won't see a bus in the mirror. The bus is on the sheet. So if you can capture something on a screen, then it is a real image. And if you cannot capture something on a screen, but it is on the mirror and it appears to be on the other side of the mirror, then that is a virtual image. So the real and virtual image. First one, this was real. This is real because you could see that the lines after reflecting converged. So that's a real image. So you can capture it on the screen. But here they are diverging. They are not focusing there. But then you see they appear to be focusing on the other side. That. Okay. So this is A dash, and obviously this will be B dash. And if you follow the same logic, then you can get B here. Okay, A dash to B dash. So this point again, as I said, is M, and I said like the paraxial. Okay, the mirror is almost flat because we are using the paraxial lines idea. So M and P are almost vertical. Okay, so with all this, then I can use this, right? If you consider this to be vertical, almost vertical P, then you see triangles FMP and triangle FA dash to B dash, FA dash to B dash. They are similar triangles, and clearly MP by A dash B dash is equal to FP divided by FB dash. The FP is what? It's focal length F, and FB dash is this focal length plus this image distance. PP dash is image distance. This is V, right? This is V, and this is F, really, and this is U, right? So this is going to be F plus V. Okay. So for this triangle you get that. And what about, can you find any other similar triangle? ABP, triangle ABP, this triangle, and P A dash to B dash, triangle P A dash B dash. Okay, so they will be these two, this triangle and this triangle will be similar triangles again, because all of them will have the same angles, or both of them will have the same angles, all corners. Anyway, so here again AB is divided by A dash B dash is equal to BP divided by PB dash. So AB, MP, same, AB and MP are the same. So this equation 1 and this equation 2 will be the same. Anyway, so what is BP? BP is U and PB dash is B. So that is 2. So 1 is equal to 2. So 1 is equal to 2. If 1 is equal to 2, so 1 is equal to 2. So this gives you U by V is equal to F by F plus V. Okay, so take these things here, then what you get here, UF plus UV equals VF, and UV now is equal to, take this there, VF minus UF, that is equal to V minus UF. So your F now is going to be equal to UV by V minus U. You see, this equation, real image, and this is for the virtual image. You have two equations for the same mirror, depending on where you are keeping the object. If you kept the object here, and then if you have a real image, then this is what you got. And if you kept the object within the focal length of the mirror, then UV divided by V minus U is the equation you got. Two different equations. But you can have one single equation if you use the sign convention. And this is where the sign convention becomes critical. When you measure these distances, if you use the sign convention, then I can straight away use one formula, which is this formula. With sign, this is without sign convention. With sign conventions, what you can do, 1 by f is equal to 1 by v plus 1 by u. Okay? So this is the formula that you should use. But if you use this formula, then as I said, if you measure the distance in the direction opposite to the direction of the light, then that would be negative, and if you measure the distance in the direction, in the same direction as the direction of light, then that will be positive. Okay, so that's the only thing. So if that is the case, let me just take the concave mirror. For the concave mirror, look at the focal length. This is my pole. Where is the focus? The focal point is here. The focal point is here. So this is P, and if you keep the mirror like that, the focal point is like this. And if you keep an object, then light will travel in this direction. But then I always measure focal point from the pole in the opposite direction. So my focal length for the concave mirror will always be negative. This will be negative. And if I use a sign convention, I will get a negative value for any kind of configuration. So it doesn't matter. Okay, whether I keep it here or whether I keep it here, this will still work. For I must get a negative. That's important. In this case, my u is a negative number. This is, I said plus. Plus this u is a negative number. With the sign, I'm not going to say 10 centimeters or 8 centimeters. I'm going to say minus 10. That's what I will put for u. The u and v and f, they are always with the sign. Your a, b, m, p, a dash, b dash, these are without signs. But when you use this formula, you cannot just measure the distance. You should also see what sign it has. You have to use this formula with the sign to get the right result. If you don't use this formula with the sign, then you will get very wrong results. So use the formula with the sign. U 10 centimeters? No. Is it positive or negative? Then put that. V 5 centimeters? Positive or negative? Then you put minus 5 centimeters. Then you will get the right answer. Then they give you the focal length for the concave mirror is 10 centimeters. Wait, yeah, 10 centimeters is the length. Then what's the focal length of the concave mirror? It will always be negative. So minus 10. So put minus 10 here and then calculate the remaining. So always use this formula with the sign convention. This formula, even though we have derived for the concave mirror, it is true for even convex mirror. Okay, it is true for the convex mirror. It is also true for any plane mirror. Plane mirror will get to know that it is 0. Okay, the focal length is infinity. Okay, so that's something that you'll get to know. Okay, so let me take the convex mirror now. Let's say let me take the convex mirror. So this is the convex mirror, right? Okay, so I'll keep an object here. You see, and this will hit here. And notice this is normal. Then it will go like this. Okay, suppose this is normal. It will go like that. Hit here, and then it will reflect like that. So it will hit here, and it will go like that. See, there is no convergence that's taking place on this side. So there is no real image that you can form with the convex mirror. So what you do is that, okay, let's say this is a ray, hits there and then it goes like that, and this is a ray that hits there and then goes like that. Now they don't converge, so this ray is like that, this ray is like that, and all the other rays in between will be like this. No, between this ray and this ray. Okay, so what you do is then you kind of extend it virtually, and then you extend this this ray appears to come from somewhere here in this direction, and this ray appears to come from somewhere here in this direction. So this is where they join, and this will be the okay. So this is where you will form the image. So you can have a vertical image. Okay. Okay. So and the focal length of the convex mirror will be positive. That's clear. So the mirror is like this. Okay. So this is where the C is going to be, right? So there is no C here because the sphere is going to be completely like that. C is here, so F will be here. And this is a pole. From the pole, how do you measure the focal length? In this direction. What is the direction? The direction in which light travels. So PF will be positive. So the focal length of a convex mirror will be positive number. So the focal length of a concave mirror, F concave, is going to be negative for this. F convex is going to be positive because it's here, it's on the other side. You can see that because you are keeping the object here, but then the mirror is curved like that, and the C is there, F is there. So this is a pole. You measure a positive distance, and your U would be negative. Your U will always be negative because you are keeping the object here. U will always be negative, and your V will be positive, and also your F will be positive. Okay, so this is what you get. And we also talk about what is called as a magnification. Okay, magnification is how much your object is magnified in the image. So it is always the image height divided by the object height, the final divided by initial. So magnification image height divided by object height. Which is equal to, this will be equal to A dashed B dashed by A B. Okay? Okay, so just like this. A dash B dash divided by A B. So you can clearly see this, right? What can you see? You can see that A dash B dash by AB can be written as PB dash divided by BP. So this is going to be equal to PB dash divided by BP. So this will be equal to V by U. Well, think about it. I said the moment you are starting to use V and U, then you must be using the sign convention. Right? Okay. Now, what is V? V is positive. Good. But what is U? U is negative. Like that. Negative. So a positive number divided by a negative number will give you a negative quantity. No. Okay? Why no? Because you see, the image here is erect. It's not inverted. And negative magnification means it's inverted. A positive magnification means it's erect. So what should you get here? You should get a positive magnification for this value. Right? Because this is the object, this image, the image is erect. It's not inverted. So I must get a positive value. But if I use V, V is a positive number. But if we use U, then U is a negative number. Then I will get a negative value for it. So how do I correct? I simply take this and multiply that with a minus sign. Okay, so this is magnification. And this will work in the case of the real object true. Remember, we did that first. In this case, it will work here. What happens there? Let me draw that picture. Let me draw the picture quickly. So you have it here. So you have the object here. So something like this happens. It's inverted. Okay, so this is your V, and this is your U, and this is your V. This is A, B. This is your A dash to B dash. So this is U, this is V, right? So what is magnification? Magnification will be equal to V by U. V by U. But V is a negative quantity and U is also a negative quantity. So negative by negative will give you positive, which means this says this is erect. It is not erect. The image is not erect. You see, the image is inverted. So then I put a negative, you see, to get the right information. If I get a negative magnification, which means that the image is inverted. If you get a positive magnification, then it means that the image is erect. So if you just take V and U, V by U, and this is a negative number, this is a negative number, then I will get a positive number. But what I've got here is an inverted image, so I will multiply by minus 1. So I get Vm is equal to minus V by U. You see, the same formula is applicable now for both these cases. For this case and also this case. But measure V with the sign. Measure U with the sign. Then you will be okay. Without the sign, you won't get the right information. So use the sign. Anytime and every time you use V, U and F, they have to be used with the right sign. When they give you a number, F is so many centimeters. The first question you ask yourself is, what is the sign? What is the sign of that F? That's what you should ask. And things will become easy from that point forward. Hope this is clear to you.